Okay, let's dive right into this explainer. Welcome to another fascinating journey into the hidden architecture of our world. Today, we're zeroing in on August 5th. And this isn't just an ordinary day on the calendar. It is genuinely one of the absolute greatest dates in all of mathematical history. So we're going to look closely at exactly why this single date is so profoundly special and how it actively shapes your daily life right now.
On this one date, spanning across totally different centuries and stretching across completely different countries, brilliant minds changed the very world we live in today. They didn't just write abstract numbers on a page or get lost in academia. They built the literal foundation of our modern technology. We owe a huge debt to these milestones, so let's meet these visionaries one by one and unpack their legacy.
But first, think about your own daily routine for a second. Have you ever wondered how the basic calculator app on your smartphone can multiply massive, complex numbers in a fraction of a split second? We totally take this instant processing power for granted today. But getting human engineering to this point took incredible vision and, well, a whole lot of trial and error.
Section 1, Frank Baldwin, August 5, 1900.
So, Baldwin tackled the exhausting problem of slow, manual human calculation head-on by inventing a revolutionary mechanical calculator. On this exact day, he was actually awarded a U.S. patent for a machine that was capable of multiplying massive 8-digit numbers by 4-digit numbers. Instead of tedious handwritten math that could take hours and, result in human error, this device could solve these huge mathematical problems in about 20 seconds. By using a brilliant system of physical gears and just 8 simple turns of a handle, he laid the direct mechanical groundwork for the digital calculators we use every single day.
And this just brilliantly illustrates how the complex digital technology sitting right there in our pockets today evolved directly from elegant, simple mechanical steps. It really puts it into perspective, right? Every ultra-fast digital calculation today literally started with this simple physical turn of a handle.
All right, let's keep moving along the timeline and see how this builds. We're staying strictly on August 5th, but now we're jumping backward in time to the year 1802. We're going to meet someone who didn't just solve a problem, but literally tackled the impossible.
Consider the incredibly complex world of modern computer science and cryptography for a moment. How exactly do we know when a code or a digital puzzle is simply mathematically impossible to crack? How do we define the absolute outer limits of what logic can actually solve?
Section 2. Niels Abel, born August 5, 1802.
So, while other mathematicians of his era were wasting their entire lives and careers trying to find a neat general formula to solve complex fifth-degree algebraic equations, Abel took a totally different and radical approach. He mathematically proved the absolute impossibility of finding a general solution. By proving that some equations inherently just have no simple algebraic formula, Abel created an entirely new framework for understanding mathematical boundaries. And this is highly relevant today, because this concept of proving a limit exists. That's exactly the mathematical logic that modern cryptographers use to build unbreakable digital walls and secure your personal data.
So, the deeply crucial point here is that sometimes recognizing and proving that a boundary exists is just as powerful as breaking one. It defines the rules of the game and tells us exactly where we need to focus our human energy next.
Okay, it's the exact same date on the calendar, but exactly 70 years later. We're moving to a completely different country in Europe and zooming out to look at an even bigger, truly cosmic idea.
Think about the GPS network you use every single day. It genuinely seems like magic that thousands of satellites can stay perfectly suspended in continuous orbit without, crashing into each other or falling right back down to Earth. But it's actually not magic at all. It's based entirely on highly predictable patterns.
Section 3. Charles Eugène Delaunay, died August 5th, 1872.
Delaunay spent the bulk of his professional life meticulously calculating the incredibly complex theory of lunar motion. By creating new mathematical models, he vastly advanced our fundamental understanding of planetary orbits and mapped celestial mechanics. His specific equations flawlessly mapped the moon's gravitational pull on objects, and decades after his passing, his life's work provided the exact mathematical foundation required to plot stable, predictable orbital tracks, which is what allows us to safely put modern technology, like communication satellites, up into the sky.
The seemingly chaotic, empty void of space? Yeah, it isn't chaotic at all. It is strictly bound by beautiful, invisible mathematical rules. And it is entirely because pioneers took the time to map those invisible tracks that we can safely navigate the stars today.
One single incredible date and so many world-changing stories. Let's check back in with our timeline and keep going forward all the way to 1986.
Here's an incredibly complex real-world problem. Earth's gravity physically warps both time and space. Because of this, time passes differently up in space than it does down here on the ground. So why doesn't the digital map on your smartphone get utterly confused by that discrepancy?
Section 4. Banesh Hoffmann. Died August 5, 1986.
Hoffmann spent a great deal of his career working intensely on the theories of relativity, and he didn't just study it from afar, he worked side by side with Albert Einstein. Together, they tirelessly formulated complex gravitational equations and worked out the specific problem of motion. This matters immensely to your GPS because satellites are moving incredibly fast in a lower gravity environment. That means time literally moves differently for them than it does for the phone in your hand. Hoffmann helped shape the exact equations that actively correct this time dilation, making absolutely sure your GPS is accurate down to the exact meter today.
Hoffmann's search for this cosmic simplicity perfectly illustrates how a few brilliant chalk equations on a blackboard can literally dictate how we navigate our modern world right now. Our entire digital mapping infrastructure is built securely right on top of their relativity theories.
Let's pull back for just a second and look at the sheer scope of our incredible journey through August 5th. We have spanned from 1802 all the way through to 1986, witnessing centuries of unyielding human curiosity.
Every single person we met today, across completely different eras, different languages, and different countries, they all fundamentally asked the exact same question. They looked at the universe and asked, what is the pattern hiding inside the chaos? And because they dared to ask that fundamental question and do the rigorous math, our world today operates with instant calculators, deeply secure digital codes, and flawless GPS navigation. Math truly does make our complex lives immeasurably easier. So my final